Okay, so to continue, next question says quadratic. What is the domain and range of the function f of x equals 2x squared minus 3? So the first thing we need to think about is our vertex. Looking at this here. Oh, thank you. Okay, what is the domain and range of the function? So we need to think about our vertex. If this equation here is in vertex form, a times x minus h, sorry, real plus, minus h squared plus k. We have an a value, we have no h value, and this is our k. So our vertex would be 0, -3. So that was a little tricky there because there was no h value for the vertex. So if we have a graph like this, just a quick little sketch, I know that the vertex being at -3, 0, -3, would be something like this, right? Where this is 0, -3. So looking at this basic graph, if the domain is from left to right, my domain would be -infinity to +infinity, and my range from bottom to top would start at that -3. So we'd have a bracket, and it goes up to +infinity with a parentheses. Okay. Next it says, what is the domain and range of this function down here? So looking at the graph, remember domain, for some reason I'm missing the graph here. Do y'all have the absolute value graph on your copy? No, it's not there? Okay, so sorry it's not there, but it was a graph, something like this, absolute value. And this point up here is at 3. So just to make a generalization, we have absolute value. Our domain is from -infinity to +infinity. And my range from bottom to top would be from -infinity to +3 with a bracket. Okay. So for our quadratic function, now this graph, notice how it does not have arrows. So it does not continue on to infinity. It stops and starts right here and right here. So our domain, which is from left to right, starting on the left, we start at -6. So our lowest point would be -6 with a bracket. It has a bracket because this circle is shaded in. If the circle was open, it would be a parentheses. So we can even make a note of that here. Shaded or colored in circle means bracket. Open circle means parentheses. So we would go from -6 going all the way to +2 with a bracket again. For our range, from bottom to top, or the y values, we start here at -4. And again, it is shaded in, this point at -4. So it would be -4 with a bracket. And it goes all the way up to 8. Now there is no hole at 8, so it is another bracket. Okay. If there was a gap or a skip or a jump, whatever you might want to call it, at the y value of 8, then yeah, we would have an open parentheses, but we don't. The graph is continuous through the point at 8, okay? All right, as we scroll down, we crossed out the factoring. We didn't get to this unit, so we'll start with that next semester. Same thing with the zero product property, you can cross that one out. And then we can cross out the greatest common factor. We'll get to that next semester. So starting here, we're getting into more of what we just started learning, the square root. So the first one, we're solving quadratic functions with the square root method. So we start with x squared plus 25 equals 0. In order to solve for x, or our zeros, we're looking for the solutions or the zeros of this graph. We would subtract 25 over and be left with x squared equals negative 25. Our next step would be to take the square root to get rid of that square, and we would be left with x equals the square root of negative 25. Can we take the square root of a negative number? No, we cannot. So our answer here would be no real solutions. Hey. Okay, so for the next one, we have 3 times x squared plus 2, which is squared, equal to 8. So when we see these square roots, I want you to focus on keeping think about what is being squared. That 3 is not being squared. That 3 is being multiplied to something that's being squared. So we want to isolate what is being squared first. We want to get that all alone. And in order to do that, we have to get rid of the 3. So we need to divide both sides by 3 in order to cancel out the 3 on the left side. That leaves us with x plus 2 squared equals 6. Our next step would be to take the square root in order to get rid of the square. So I noticed some things on the quiz. We're not just taking the square root just because that's the next step. We're taking the square root to cancel out the square, the little 2. It's just like multiplication and division. The 3 is being multiplied to something. So in order to get rid of the 3, we have to do the opposite of multiplication. We have to divide. So we are trying to solve for x. And so in order to get x all alone, we have to slowly peel back all of these pieces, all of these layers touching and covering x. First, we got to get rid of that 3. Now, the only next thing we can get rid of is the square, the 2. And in order to do that, we have to do opposite of square, which is square root. So that's why we do it on there. We're just trying to get rid of the square. So those cancel out, and we are left with x plus 2 equals plus or minus the square root of 6. So we already have to take the square root of something, and we've isolated, or we got rid of the house, the square root. So now we need to go into our 2 solutions. I'm running out of space, so I'm going to continue up here like this. So we have x plus 2 equals the positive square root of 6. Sorry, it looks kind of negative. Messed up there. And then over here we have the negative square root of 6. I probably should have, well, no, you can't really. That's fine. That's fine. Okay, so we're going to subtract 3 from both sides. Oh, I'm sorry, not 3, 2. I got distracted for a moment and I threw myself off. Minus 2, minus 2. Oop. These cancel out, and we're left with x equals either negative 2 plus the square root of 6, or you can write it as square root of 6 minus 2. With that minus 2, do not do this. This is the incorrect answer. You cannot put negative 2 inside the square root. The negative 2 was being subtracted from the square root of 6. It's not being square rooted at all, okay? So make sure you don't do that there. And for the negative answer, we're left with x equals negative 2 minus the square root of 6, or you can switch it up and say negative square root of 6 minus 2. Either one of those answers are fine. Do we have any questions there? Okay. The only reason we didn't break down 6 is because there are no perfect squares that go into 6. You can't square anything to get 2, and you can't square anything to get 3. 2 times 3 is 6, but you can't square root those numbers and get a perfect square. Okay, so that's why we just left it at 6. It's already simplified, can't go any smaller. Okay, so let's go ahead and move down. We're getting back into completing the square, And as a reminder, when we are using completing the square, we're doing this to transform a quadratic equation in standard form. We're transforming it back to vertex form. So what we're going to do here, our first step, since there is no coefficient out front, the x, we're going to look at our b value, which is 14. So remember we said b over 2 squared in order to get the number that's going to be added and subtracted from the equation. So 14 over 2 squared, 14 over 2 is 7. 7 times 7 is 49. So 49 is the number that's going to be added and subtracted from the equation. So we'll say plus 49 on this section, and then minus 49 on everything that's on the outside. Once we get here, you're going to look at the middle number here and its sign. If it is positive, you keep the positive. If it is negative, you keep the negative. So the sign comes down, and then for the 14, we're going to divide it by 2, and that will give us our number that goes here. So 14 divided by 2 is 7. So we'll have x plus 7 squared, and then this will give us our outer number here. So negative 51 minus 49 gets us negative 100. And that's our answer. So really not that bad when there's not a coefficient in front of the x squared. There's a little bit less steps and makes a little more sense. So if over here it's asking for our standard form and our vertex form, I'm just going to write the originals, which are standard form is ax squared plus bx plus c, and our vertex form is ax minus h squared plus k. All right, so to do the next one, again, we're going to look at our b value because this is a, b, and c. If our b value is 12, we'll say 12 over 2 squared. 12 over 2 is 6. 6 squared is 36. So this is the number that's going to be added and subtracted from our equation. Remember, we're adding it to this section and subtracting it to the c. The reason we break it out into two separate sections is because the first section has a variable x. The second section is just a constant, so no variable, just a plain number. So we add to the variables and we subtract from the plain numbers. We did a lot of practice on this, so if you feel that this is what you're unsure of, open your folder, find an old practice, and try to work through some of those problems on a separate sheet if you've already completed them. All right, so we're going to add 36 and we're going to subtract 36. And now we're going to write in our vertex form. We're going to look at the negative and the 12. The negative stays the same, so that comes right down. The 12, we half it, so we have x minus 6. And then we get our outside number here, and that gives us what our new k value. So 23 minus 36, that gets us negative 13. And there's our equation. So this center value here, or our new b value, gives us our h, and what's on the outside, the constants, give us our k value.